I would like to start this class with a pop quiz. Quick question. So, are you ready? Okay, let's go. So, there are five pictures, five maps in front of you. So the question is, which out of these five pictures is or are the representation of the Earth? Which of these are the map or maps of the Earth? If you think you know the answer, please write them in the comment below. So, if you think you know which of these five pictures is the Earth, please write it down in the comments below. The first person to come up with the right answer will get a prize, and you'll not be disappointed. Okay, so let's start with today's class. Unit 7, Roving Continents. Does everyone know what roving means? That's right, roving means traveling from place to place. So as we all know that our planet is in constant motion, it keeps spinning, it keeps moving around our sun, right? But did you know that the ground that we are standing on is also in constant motion? That's what we're going to read about in today's lesson. So if you will, please open your books to page 97. Page 97 of your textbooks. So in this unit, you will learn how scientific discovery led to our current knowledge of the movement of Earth's outer layer, the crust. And that's what we're going to learn about. What is the crust? Okay, we'll read about exciting changes in the Earth's crust in one part of the world. And finally, increase your understanding of the target academic words for this unit. And some of these words will be related to the field of geology. And geology is the study of the rocks of the Earth. I'd like to lead our first lesson with several questions. What continent do you live in now or live on now? What's the name of the continent? Do you know? Is it connected to other continents? Have you ever lived on or visited another continent? So I would like you to share your thoughts, your ideas, your answers in a comment below, and you can, uh, chat among yourselves. Okay, so leave your thoughts, your experiences regarding two continents. Where are you living now? Which part of the world are you living on now? Is this continent that you're living in, is it connected to other continents in the world? Have you ever visited other continents? Okay, that's the first question or first series of questions. Okay, so next, have scientists discovered any evidence that the climate on your continent was once very different from what it is now? What caused the change or changes? Have you read any news article or scientific journal saying that the place, the area that we live in used to be very, very different? Have you heard anything? Have you read anything? Have you watched anything, any documentary on this? If you have, please share your experiences, your knowledge on the comment below. And finally, Name two parts of the world that experience a lot of volcanic eruptions or earthquakes. Just name two parts of the world that you know that experiences a lot of volcanic eruptions, a lot of these uh, lava spewing or earthquakes like land shaking. What do you think causes these events? If you don't really know much, you can just leave one, at least one. Okay, good. Um, so, in order to understand this unit, I would like you to explain about two words. These words are on page 98 of your textbook. Well, the first word will be continent. Continent. And what is a continent? It's a large landmass. It's a large piece of land. And presently, we have 7 continents. There are 7 continents. Did you know that? Yeah, Africa, Antarctica, Asia, Australia, Europe, North America, and South America. So there are 7 continents in the world today. And the next word is theory. Theory. And this particular word means a systematic explanation of how something works. A theory tells us how something works. That's the theory. Okay, so with that, let's start today's lesson. Pieces of a puzzle. The evidence for PANGAEA. So the title tells us that we're going to read some of these evidences that was brought forth to explain about this mysterious land called PANGAEA. In geology, a plate is a large rigid area of solid rock. So in the field of geology, where they study rocks, the word plate refers to this solid landmass. The Earth's surface is built of about 40 plates called tectonic plates, some as large as continents and others only a few hundred miles across. So the Earth that we are standing on is comprised of about 40 plates, pieces of lands. So this is what it looks like, a simplified version of plate tectonics. There are about 16 of these plates represented here. As you can see, mostly these are the big chunks, the larger pieces. There are smaller pieces than this, but these are basically roughly what plate tectonic looks like. So there are about 40 of these, and they're called tectonic plates, plate tectonic. And some of these sizes, as you've seen earlier, they are huge pieces of land, some bigger than continents, and others that are not represented in the picture. They're only a few hundred miles, few hundred kilometers across. Modern geology has shown that these tectonic plates move in relation to each other. They are like, pieces of puzzle, they are stuck together. And if one moves, it will affect the piece that is lying next to it. So they are in constant, they constantly affect each other. So that's what it says. They move in relation to each other. And we could be asking these kind of questions. How could a solid piece of land could move? And the answer lies here. Such movement is possible because the plates float on top of the mantle, the layer of molten rock between the planet's outer crust and its dense nucleus, called the core. The reason that the outer layer, the plates, or the outer crust can move is because the crust, the plate, is on top of this area called mantle. A mantle is comprised of molten rock. And what is a molten rock? Molten rock is rocks that are in such a high temperature. They are lesser solid and more like a liquid. They flow, they move about. And because there's a layer of mantle inside under the plates can slowly move. Again, so where do these mantle lie? In between the outer crust and the inside core, the center of the planet. Even before this theory of plate tectonics became accepted, many in the geological community believed Earth's continents had moved during the history of the planet. So, even before this theory of plate tectonics were brought forward and many embraced it, many people who were in the geological community, people who worked, who studied geology, many of these people believed that Earth's continents may have moved sometime in the past. But many did not expect to this extent that the Earth has been moving, still in constant moving motion, and it will move in the future. They were right, but their ideas faced great opposition. They were right about Earth's surface, landmass, continent moving, but there were a lot of people within the geological community and from the outside. They did not accept this idea when it first came out.
The ground beneath our feet is always moving. We don't feel this often, but we can see the results of the movement almost everywhere. The Earth's crust is what moves. Our planet's outer shell. It is not one piece, but instead is made of individual puzzle pieces, plates. They were all part of a continent that broke up over 200 million years ago. Since then, it hasn't stopped moving. This is called tectonics. Plates move slowly, as fast as growing fingernails. Continental plates form the land the continents are on. Plates that are covered with water are called oceanic plates. They are thinner and the rock is heavier. When continental plates collide, the folds can pile up and create huge mountain ranges up to 8 kilometers high. An oceanic plate pushes itself under a continental one. It disappears into the Earth's hot mantle, creating an ocean trench up to 8 kilometers deep. On its way down into the mantle, the oceanic plate melts. But the liquid magma can return to the surface at another place. A volcano is born. When two oceanic plates move apart, the seam is called an ocean ridge. Magma from inside the Earth escapes here. This drives the plates further apart and makes them grow. Plates that glide past each other can get tangled up and stick. When they separate, the Earth shakes. Earthquakes show our planet is anything but a calm place.
Does anyone know where this place is? Does this picture help? That's right. It's the Grand Canyon. How magnificent is it? Does anyone have wondered how this tremendous place was formed? Some people have one idea while the others have another. There have been many theories um, involving this place. There have been two prominent positions, and that's what we were going to read about in the next part of our article. So let's find out. Sudden events. Until the 1700s, most Europeans explained the origins of Earth's bodies of water and land masses in terms of catastrophism. So, up until the 18th century, the majority of people in Europe, they believed that the Earth as they knew it, or as we knew it, came to be during a relatively short period of time. So what is catastrophism? In geology, catastrophism theorizes that the Earth has largely been shaped by sudden, short-lived, violent events, possibly worldwide in scope, just like Noah's flood. According to this explanation, a few sudden violent events, catastrophes, periodically transformed Earth's surface. Many people back in the day, they believed in the biblical interpretation of the world history. And the Bible tells us that during the time of Noah, the whole world, the whole earth was covered with water. And during this event, the earth was formed, changed, transformed into the world that we know it. Then, a revival of science in Europe restrained the imaginations of geographers. Since the time of Renaissance in the 16th century, science was a big decision maker when especially the intellect thought about how Earth was formed and also how the physics, the workings in the world, in the universe worked. So if it was deemed outside the realm or the knowledge of the science, the ideas were discarded. Catastrophism was displaced by uniformitarianism, a term derived from the word uniform. So the notion, the concept of catastrophism was pushed back by new thinkers, and in its place came the notion of uniformitarianism. But this concept is not a noble one. This notion of the earth have been here in this state in the past for a long period of time, and it will remain the same in the future to come. This notion was, was here with us for thousands of years. So what exactly is uniformitarianism? In geology, uniformitarianism has included the gradualistic concept that the present is the key to the past, and that geological events occur at the same rate now as they have always done. According to this explanation, the forces we see shaping the Earth now are the same forces that shaped it in the past. So if we can understand the present, then we will be able to predict what happened in the past, because the past won't be so that different from the present. Since most of the processes we see are slow and gradual, we assume that for the most part, Earth's surface was shaped slowly and gradually. So when we observe the Earth, our surrounding, our nature today, we see everything moving so slowly, the changing. We see the change, but these changes don't drastically change. So the people who believe uniformitarianism think that the past, in the distant past, is not that different from the things that is happening today. But we have to remember, many modern geologists no longer hold to a strict gradualism. They have a different concept, slightly different. I mean, it is similar, but it's slightly different.
But the idea of millions of years of uninterrupted gradual change is now being challenged by many scientists. Astrogeologist Dr. Eugene Shoemaker at the Lowell Observatory was one of the team that discovered the Shoemaker-Levy comet. He disagrees with the creationist time scale, but his research on impact theories shows that dramatic catastrophic events have shaped the face of the Earth.
The view that we have of the role of large impacts today actually challenges the old paradigm of uniformitarianism right to its roots. Indeed, the notion that comets might hit the Earth and produce catastrophic changes is an old one. It goes all the way back to Edmund Halley in the 17th century. And it was part of the background of the debate that occurred in the 19th century between the advocates of catastrophism on one hand and uniformitarianism on the other. It turns out in the 19th century, the uniformitarians won the debate at that time. But in fact, they were wrong, or at least partly wrong, and the catastrophists were partly right. So we really have to reassess this whole idea of uniformitarianism, which has been taken now for several generations to be an underlying principle of geology. It just simply isn't right.
Gradualism is still the foundation of modern geology, but mounting evidence of catastrophism is causing geologists to revise the conventional theories. Creation scientists believe that the greatest catastrophic event in Earth history was a recent global flood that destroyed almost all life and shattered the continents. Their claims are supported by studies of local catastrophic events that can be observed today.
We do know of catastrophes that occur today, volcanic eruptions, earthquakes, tsunamis, hurricanes, those sorts of things. And we can certainly, in a sense, apply the same principle, the present is the key to the past, and we can actually look at rock units and geological processes that are catastrophic in the present, and we actually see those features in the rock record. And that gives us a clue that maybe the past wasn't all that quiet, and when you've got fossil upon fossil upon fossil that show evidence of catastrophism, it begins to give you a different picture of the total geological record as somehow not being a slow and gradual thing. It points to a catastrophic past in the Earth's history.
Under the fragile crust, Yellowstone National Park in the Northern Rockies is a seething cauldron of geothermal activity. Sometime in the past, powerful volcanic explosions blasted through 1,000 square miles of rock, hurtling debris as far east as Kansas. At Yellowstone, several layers of petrified trees are found standing upright. How did extensive forests become fossilized? It's widely claimed that the trees were gradually fossilized where they grew millions of years ago. But a new theory developed by Dr. Stephen Austin at the Institute for Creation Research in San Diego suggests the trees may have been uprooted in a sudden catastrophe, swept away and rapidly buried. The creationist model was seen in action during the eruption of Mount St. Helens volcano in 1980, when thousands of trees were swept from the hillsides and deposited in Spirit Lake.
One of the things that most puzzles me about the conventional way of thinking about the Earth is fossil deposits. The fossil forests here at Yellowstone are distinct layers. We find petrified wood. Do those represent 27 distinct fossil forests which flourished millions of years ago? The signs at Yellowstone here used to say that. They used to say that there were countless tens of thousands of years involved with each of the forest layers, and that the whole rock strata sequence took 40 million years to form. But as we look at those fossil deposits, we see that they're similar to some of the things that happened at Mount St. Helens volcano. A whole series of upright logs were deposited at Mount St. Helens in the bottom of a lake. And the mud flows at Mount St. Helens made stratified deposits with upright logs embedded in the deposits. And each of these may look like it was a separate forest over many, many thousands of years, but this process of redepositing logs creates what in our ordinary experience looks like would require millions of years. The modern thinking about this may indicate that catastrophic processes are better at making fossil wood deposits and even upright logs embedded in the rock strata than the slow and gradual processes are.
The belief that continents have not always been in their present positions was common long before the 20th century. So this particular belief was common, meaning it was a part of common sense. A lot of people believed in this. And this belief was there long before the 20th century, meaning it's been here for a long, long time. And what is this belief? And this particular belief was that the continents, the lands that we are living on, the location of these were in a different location sometime in the past. And a lot of people believed in that. The land that they were living on, standing on, was not always there. That was the common belief, common perception. And this perception was with them for a very, very long time. In 1596, the Dutch mapmaker Abraham Ortelius suggested that the Americas were torn away from Europe and Africa by earthquakes and floods. So about 300 years earlier than the 20th century, the Dutch mapmaker, this is what he suggested after, I'm sure, he studied many of maps since he was a map maker. And after studying a lot of maps, a lot of the shapes of continents, he figured out that the shape of Africa, in one particular part of Africa, nicely fitted with a piece from South America. And this is what he suggested. Americas, North and South, they were once with or attached or joined together with Europe and Africa. But sometime in the past, due to earthquakes and floods or other natural occurrences, these land masses split and moved away from each other. And the expression they used was tear away, torn away. It was like ripped apart. he pointed out that if you imagine putting Africa and South America together, they would fit almost like two puzzle pieces. Just like this. So he pointed out that the shape of Africa and shape of South America, they fit together nicely, just like two puzzle pieces. The big opening along Africa's western coast would nicely accommodate the hump in South America's eastern coastline. So the western coastline, the big opening, the Gulf, the shape of it is nearly, it's not exactly the same, but it nearly matches the eastern coast of South America, the big pointed part called hump. So what do you think? Do you think these two huge continents once were attached together? Do you think what this Dutch map maker have suggested? Do you think it's true? Please leave your your thoughts in the comments below. In our next class, we want to learn about Wagner's theory of continental drift. So until then, I hope you keep yourself safe and sound. I will see you next time. Bye.